Good morning, everyone. I'm Professor Bob White. It's my pleasure to welcome you to our second senior project presentation this morning. This is part of the Senior Engineering Design Conference that we have here at the university. This is the 70th conference that we have, hosted by the College of Engineering and Applied Sciences here at the beautiful Parkview campus. I'm humbled and pleased to say that I've been able to be to all 70 of those conferences. Students sometimes ask, how long have I been teaching here at Western? I always say 412 years. I think some believe me. It's indeed a pleasure to have all of you with us. This is a very proud moment for the students. They've worked very hard on these projects. And it's always pleasing and satisfying as faculty members to see these people come as young freshmen, a little bit apprehensive, and grow into these confident, capable seniors that you'll see in front of you. I think you'll be very impressed with their presentations today. While it's not always possible to have people with us, family members, when we do, we like to recognize them. And we have several family members with us this morning, both in person and online, and we welcome our online streaming participants as well. We have Bill, Ian, and Colleen here with Megan. Bill, Ian, Colleen, I believe, is online. Welcome, Colleen. For Anthony, we have Antonia, Perry. Very happy to have you with us. And for Connor, we have Alice and Peter. Again, very happy that you could make it with us. You sent us these students a few years ago, and freshmen, not sure what they wanted to do, how to do it. I think you'll be very impressed with what you see here today. The presentation topic is trimming room process improvement. Again, we have Megan Gessler, Anthony Mastro, and Connor Mulhern.
Alrighty, guys. Well, my name is Anthony Mastro. This is Connor Mulhern and Megan Gessler, and we are doing our senior design presentation at Ahki Canna. What Ahki Canna does is they cultivate cannabis and sell to smaller dispensaries. So our project is focusing mainly on the trimming room process and kind of how to make that process more efficient. So, Jennifer, today we'll go over a little bit of background information, tell you what Ahki Canna is all about. We'll also go over a process overview on how they cultivate their cannabis, and then we will also go into our analysis in that trim room, and then show how we got our deliverables from that analysis in the trim room. So first, a little bit about the industry growth of recreational cannabis. This graph on the left here, you can see in the past 2 years, sales for recreational cannabis have grown rapidly. This is due largely to the fact that there has been a 56% increase in recreational cannabis dispensaries throughout the state of Michigan. There are over 256 dispensaries now in Michigan alone. And because of this, Ahki Canna has seen a great demand for their product and also a increase in competition. Many of these companies are looking to increase their efficiency for their processes to beat out their competitors. A little bit about Ahki Canna. They are located in Kalamazoo, Michigan. They are a relatively new startup company of about a year and a half old. What they do is they grow, they dry, and they trim cannabis, and then they do business-to-business sales to other smaller dispensaries throughout the Michigan area. A little bit about this picture and the pictures you'll see on our transition slides. They are from Ahki Canna. There was a little journal article written about them, and it just kind of gives you a sense of the life there at Ahki Canna. So our company sponsors are Raphael Thurn and Lyndall Morley. They've been helping us understand kind of what Ahki Canna is all about, their processes, what they do. And then our faculty advisors are Dr. Jim Burns and Professor Dana Hammond. They've been kind of helping us brush up on our engineering skills and kind of show us how to actually make deliverables for a company.
So now we'll get into the process overview sort of as to what Ahki does. So Ahki grows cannabis, they dry it, and then they trim, process, and package the cannabis, and then it's sold. We're really focusing in on the trim, processing, and packaging because the growing process is fairly complicated and it doesn't really have much room for change. Same goes with the drying process. And Ahki themselves also really expressed interest in us working in the trim room. That's where they experience lots of inconsistencies. So what goes on in the trim room? The cannabis comes in untrimmed in these big 20-gallon buckets. and it is trimmed. During the trimming process, it's sorted into different sizes. The ground up shake, as they call it, goes into the pre-rolls, and then the bigger buds go into their own packages. And then after that, the cannabis is sold. As you see on the right, these are the actual products that Ahki does sell to other dispensaries. And so really focusing in on that trim processing room, that's where they had the most manpower, and that's where they also experienced the most amount of changes. And so again, that's really why Ahki wanted us to focus on that area. A big change example. So they started off manually trimming each bud and each piece with shears. 6 operators would scoop their bowl into one of those buckets of cannabis, and then manually trim with shears, then place it into their own container, and then into packaging. Over the winter, they implemented a automatic trimming machine. This machine, all they have to do is they set up the trimmer, they have the trimmer operate for 2 hours, and the trimmer itself already divides its size into different compartments. So it'll divide it into that shake and the bigger buds. And then an operator will trim any excess if needed, sort of as a last quality check. And then it would go into its own packaging. And this new implementation actually wound up saving them 25 manpower hours per harvest. Each harvest happens about every 18 days, and that's the biggest and most busy time for Ahki. And it also wound up freeing 4 other operators to be placed elsewhere in the company.
Next, we will go into some analysis of the trim room. So the first step in analysis is creating a fishbone diagram, which helps get to the root of a problem. The problem that we chose to focus on was inconsistencies in the trim room. We focused on 6 main areas, which were materials, methods, manpower, equipment, environment, and measurements taken in the trim room, of which we found 11 problem areas. So next, we have to quantify these problem areas so that we can list them in order of importance. So we use the FMEA order of importance diagram, which stands for Failure Mode Effects Analysis. So it basically tracks the severity of a problem happening, the likelihood of occurrence, and the likelihood of detection of the problem. So the final score accounts for severity multiplied by occurrence multiplied by detection. So next, we formulated a Pareto chart, which displayed that the top 5 problem areas account for 80% of Ahki Canna's problem. And of these 5, they can be condensed down into 3 main focus areas, which are management metrics, ergonomics, and process flow, which I will go into a little bit more detail on the next slide. So for process flow, we're going to be looking at pour storage and layout and the fact that the equipment varies from operator to operator. For management metrics, we will be looking at the fact that they're teaching different methods, that they are taking different measurements, and that they do not have visual posted on the walls. For ergonomics, we're going to be looking at workstation layout and tables and chairs, and these will be our 3 main deliverables.
So going into our first deliverable, we wanted to look at process flow. And to really understand the process flow, we had to understand the current layout in the trim room. So we did some studies in the stations highlighted in orange here, where the main stations were the material, or in this case, the bud would touch. The stations highlighted in gray were stations that the bud did not touch. Further studies, we found out that the bud comes into the room in that 20-gallon container there. It'll make its way to the automatic trim station, where it is divided into 2 different bud sizes. The first one is a smaller bud size, which will go to the grinder to be turned into shake, and then to a pre-rolling station where it's turned into a joint. And then from that pre-rolling station, it is brought to the packaging table and sealed up. Same kind of thing for the bigger bud. The bigger bud instead, though, goes to the operator tables where it's measured into 3.5 grams and then put into a small container and then brought back to the packaging table where it is again put into a box and then sealed up. And then from the packaging table, once everything's all sealed up, looks nice, got a label slapped on it, it'll just go back out the same door it came in. So after really learning about the layout and understanding how the layout worked, we wanted to make this layout as efficient as possible. So what we did was we made a system of relationship diagrams to see the relationship between each of the stations. The first relationship diagram we made was a ranking system, which consisted of a rank from A to X, A being that these stations absolutely needed to be next to each other, all the way down to X, which showed that the stations did not need to be next to each other. This led us to our relationship score matrix, which you'll see up in the top here, where we gave each of the ranking a score. We gave it a score. A was 1 all the way down to X equaling 10. And the reason we did increasing order like that is because our third matrix, we talked about distance. And for distance, we wanted to have the least amount of distance traveled in that trim room. So the distance that we measured was in steps, but backtracking back to the relationship score matrix, once we gave each ranking a score, we went ahead and tallied up the totals at the end here. And if we found a high number, like in this case, we found 84 for office supplies, that would need further investigation as to why that score is so high and why that score or why that station does not need to be next to other stations in that trim room. So our third step was to make a distance matrix, and from that we went into Ahki Canna and physically measured these distances by taking the steps ourselves between these stations. This led us to a layout score by multiplying the score matrix times the distance matrix. For the current layout score of Ahki Canna, we got a layout score of 1,915. So after looking at that, we thought we could make improvements on the trim room based on the layout. So we went ahead and did further investigation on that office supply station. Through that investigation, we found that one, we didn't really see any operators go to that station throughout the day. Two, the material actually never touched that station. And then three, we actually conducted operator interviews and said, you know, like, what's up with this station? And many of them actually didn't even know what was in that station. So for our new layout, we took out the office supply station, and then we rearranged those main orange ones that the bar does touch. We kind of organized those into a smaller area where less distance would be traveled. And following the same relationship diagram system, we were able to come out with a layout score of 1127, which was a significant increase in layout efficiency. After looking at layout efficiency, we wanted to look at equipment in the trim room. We wanted to see how effective each piece of equipment was within the trim room. So we looked at a tool called overall equipment effectiveness, and I looked at things like availability, performance rate, and quality rate. What availability is lost time during a shift over total time during the shift, and that would come out as a percentage. For performance rate, we looked at actual equipment speed over the designed equipment speed. And then we also, for quality rate, is just number of good products over the total number of products that were made. And then to get an OEE rating, all you do is multiply each one of these percentages together, and that'll shoot you out a overall effectiveness rate. And I do want to point out we use the word equipment here. That could translate into either a worker or machinery, since both of them have kind of the same effect on throughput in the trim room. So to show how this tool kind of works, we went ahead and looked at an example. If you remember from earlier, we talked about the high frequency of changes within the trim room at Ahki Canna, and one of those changes was a manual trim station to an automatic trim station. So we went ahead and looked at availability. And for the trim station, we looked at things like worker breaks. So they're regular, 30-minute lunch break and then another scheduled 30-minute break. We looked at bathroom breaks and just kind of how often they left their station. For the automatic trim station, availability came down to it only needed a 30-minute setup and a 30-minute takedown. We then looked at performance. We gave a subjective rating for the manual trimmers, the operators kind of based on the pace that they were working at. We got them at around 70%. We looked at the automatic trim station. The performance rating for this was based off of how often this automatic trimmer either jammed, how often it needed to be cleaned. And then we took a look at quality. That came down to bud that fell onto the ground. If bud fell to the ground, that would be considered dead. They weren't able to use it. And the reason why the quality rating is so high here is because Ahki Canna does recycle their material or buds throughout the trim room. So if a bud is too small or not up to their standard size for being big, they would send it over to that grinder station we talked about earlier. They'd grind it up, turn it into shake, and then into a pre-roll. So lots of the material in Ahki Canna is recycled. After looking at all these things, we came out with an OEE rating for the manual trim station to be 51% effective. And for the automatic trim station, we came out to be 69% effective. So that was a significant increase in effectiveness for the equipment used in the trim room. Through further investigation, we found that 60% is kind of the typical threshold for discrete manufacturers. So not only did the automatic trim station show that it was more effective than the manual trim station, but it also was 9% higher than that threshold that discrete manufacturers kind of look for. So moving forward with our first deliverable, we wanted to give Ahki Canna this layout planning tool of the system of relationship diagrams. This will be able to give them comparisons of the layouts or any future layouts that they have that they want to kind of implement. It'll show stations that are not utilized throughout the trim room. So in that example, we found, 84 was a high number. We actually, through further investigation, found that that station doesn't need to be in the trim room. And then also what this tool will do is show physical distances between the stations within the trim room. The second part of the first deliverable, we wanted to give them an overall equipment effectiveness tool. And this will kind of just show how effective each piece of equipment in the trim room is. It'll also be able to compare old equipment to new equipment. So if they implement a new one, which they usually do because they do have a high frequency of change, they'll be able to measure that up against old equipment. And then it'll also be able to keep track of employee performance based on the rating they're given.
So now we'll get into the second deliverable where we look at the ergonomics of the tasks and workstations. And so we started off by analyzing the labeling, pre-roll, and packaging stations. And to do that, we performed a rapid upper limb assessment and rapid entire body assessment. As you can see on the right is the form for a REBA. And each of these came out to be scores of 4, which mean they need to be looked at and need to be changed. Mainly those are due to the neck being bent more than 40 degrees down and their back also being bent due to 20 degrees, lots of wrist movement, and repeated small range actions. As you can see in the picture, he's really hunched over, his neck's bent down, and the table just looks a little too low for him. And so our immediate recommendations are adjustable chairs and desks. They have been proven to reduce neck and back pain in standing workstations. And we looked at the prices for these. Adjustable desks range from about $200 to $300 per table, and adjustable office chairs range from $50 to $100 per table. These prices really still align with their old chairs and desks, which are these pictured here. Those are the exact tables and chairs that they have right now. And so we really recommend more adjustable tables and desks to accommodate workers. We'll look at the workstations themselves now. So as you can see in the pre-roll station to the left, it's fairly disorganized, not very much flow, not really any standard process there. And so we looked at standard work instructions given to us by the floor manager, and we're able to implement new workstations to sort of reduce the amount of range of movement as well as improve the flow of the task itself. Did the same thing here with the packaging station, and as you can see on the left, he's covering up metal tray and bowl, but in this process they take the bud and then they place it on a scale and then place it into its container and then shipping box. And so we really wanted to change the flow of that, and so we put the scale and bowl directly in front of the operator. And so now the operator just has to take it out of the bowl, place it into the scale, and then grab a jar, grab a lid, place it on, and then put it into the packaging box. And so we spoke with the floor manager and the operators, and they're each open to change. They started the ordering process for the chairs and desks, and we took some initial observations of time studies before and after implementing some of these recommendations, and that's where these numbers on the table to the bottom come from. So before recommendations from the time studies for pre-roll packaging, it was at about 4 boxes per hour, and then after the recommendations, went to 5 boxes per hour. Same with the 3.5 gram packaging, 1.5 boxes per hour, and then following improved by 2.2 boxes per hour.
So our final deliverable is going to cover management metrics. First, we had to create a solution. As you can recall, our top problem areas in the management metrics were that they did not have any labels on the wall, different procedures were taught, and different measurements were taken per operation. The goals of our solution are going to be to standardize daily tracking, to compare historical data with new data, and to find a way to display management metrics in a more useful way. And what we ultimately decided was that an Excel system was needed. Now we have to plan the Excel system. We took time studies for each process to determine a baseline for each process. We did management interviews to see if they would be open to the idea of having an Excel spreadsheet. And they actually did have a current tracking system. It wasn't very sophisticated, and it didn't do what they wanted it to do in terms of having a dashboard or being very useful for their employees. So then we did employee interviews to see if they would be willing to fill out a worksheet every day to supply us with additional information. So overall, the system is going to have data entry, a database, and then it will all lead to a dashboard. Here's an example of the daily employee survey. This will be passed out in hard copy form to the employees at the start of each shift. They record the date, their name, the hours that they worked that day, the task that they worked on, the number of units processed while they were working, and the amount of time spent on the number of units they processed. Here's an example of data entries. So at the end of each day, management takes those hard copy sheets, enters them into this database, into the form, and then it goes into this database. So the characteristics of our dashboard are that it is customizable, which I will go into more on the next slide. It is optimized for a 56-inch TV screen, which is what they use in their boardroom, which is where they meet with employees for their daily meeting. And it generates stats for their whiteboard, which as of right now, the whiteboard in their working area is only updated about once a week with useful statistics, but now they will be able to update it once a day. So the impact that this dashboard will have is that it will help management set realistic goals for their employees. So going back to the example of the trim room, operators' goals for trimming by hand were to trim 2 pounds per day, and they haven't set a new goal yet for their operators using the machine. So this is an example of the dashboard. Right here, they're adding Mara back onto this graph. The graphs are editable, as in you can remove or add more employees, and then you can change it from today's date or all dates in the database. So right now, all these graphs go back to the beginning of December. And then taking it back to deliverable 1 over on the left, the OEE and the layout score are from deliverable 1. So the overall recommendations that we have for Ahki Canna for material flow are to use the layout planning tool when moving around the layout room, to use the OEE tool to determine new products to purchase, and as well as analyze old machines. For ergonomics, we would like for them to implement the improved workstations and also work them into their SWIs that they're currently working on, and order new tables and chairs that we recommended or something similar. And for management metrics, we would like for them to fill out the daily survey, enter it into their database as good practice every day, and use the dashboard to compare employees and etc. And that is it for our presentation. Does anyone have any questions?
Time for a question. Does anybody have a question about the group? Because I have one. When you guys were doing your OE metrics on quality, did you guys do a analysis post layout change, or was that not implemented during your project?
So mainly just the way we looked at the quality is we just measured the few times we were there, we measured the bud that fell onto the ground, and then we kind of measured that into grams. You're asking post.
Was there a change in the loss rate when you did the layout change? Or
There was a change. It wasn't very significant in terms of In terms of quality, the automatic trim station was a little bit easier because what they did was they just took the bucket and then poured it into the automatic trim station, or the automatic trimmer, I'm sorry. The manual trimming kind of just came down to the operators being careless with the ball and dropping bud on the floor more often than they would with the automatic trimmer.
If you have any other questions for the group, they will be available outside. Real quick, Ryan.
Sure. What impact did the lack or presence of training standards have on the output of the system? Was that?
I think the lack of training kind of just came from this process being so new. So they did have a high turnover rate of operators within the trim room. So it was kind of hard for managers to keep giving their employees or operators within the trim room kind of a standard to meet every time. But with the management metric tool and then this OAE tool, it'll kind of keep track of how they're doing and kind of give the managers more of an idea on how to train their operators.
Thank you very much, gentlemen.